Hello, in this example I'd like to talk about the WebAssign Module 5 homework problem number 58. And in this exercise they refer us to an example in the textbook, and that example is 4.54. I've included some of that information here. So in that example 4.54, they give us an algorithm. They say let x sub 1, x sub 2, all the way up through x sub n be an array whose elements can be compared by the total ordering less than or equal to. And the algorithm we're going to work with here looks like the following. On the first line, we set x sub 1 equal to m. So the first thing that we do here is we come up with a value for m, and what m is going to be equal to is whatever the first element in that list is. So if it's a list of numbers, it's just going to be whatever that first number is. Okay, so that's what m is going to be. Now we move down to the next line, and this is the beginning of a for loop. So for I, an element in the set 2, 3, up to n, we're going to do the following. If m is less than x sub I, then we're going to replace the value of m with this new x sub I value. And if that condition is not met, we just skip it and move on, incrementing our index up to the next value in this little set. All right, that sounds a little bit complicated, but let's work through the trace to see exactly how this would work. And just to play around with some numbers, we'll pretend that n is 5 and that x sub 1, x sub 2, and so forth are given by these particular values. So what I'm going to do is I'm going to rewrite this pseudocode here with the particular values for n and x sub 1 and so forth. Okay, so I've rewritten things over here. Here's our list of values. So x sub 1 is 77, x sub 2 is 54, x sub 3 is 95, and so forth. So there's our 5 values, x sub 1 up through x sub 5. And I rewrote the first line. M is replaced with x sub 1, so that's what we set m to. And then we hit the for loop for I in the set 2, 3, 4, 5. We're going to do the following. All right, so let's begin. What the trace is, it's just a list or a table of all the different values that your variables take on as you step through this code. So we're going to pretend that we're a computer and we're going to execute this code, pencil and paper, or here on my screen. The first thing I'm going to do is make this little table. So I've got the variable m. I also have I, that's the index, and then we also have x sub 1 up through x sub 5. We're interested in counting the number of comparisons. This little check, is it less than, all right? So on the first line, let's just write down the given information. The very first thing that's happening right here is we're given the list of numbers. So that's the first line, and that's just given information. On the next line, what is m equal to? Well, as we step through this code, m gets set to be x sub 1, and x sub 1 is 77, so I'm going to write down right here that m is 77. Again, the values of our x sub 1, 2, 3, so forth do not change. There's no comparison that's been done yet because I'm only on this second line of code, so nothing happens there. Now let's move down the code. We are now entering the for loop. For I in the set. So the first thing that's going to happen for I is that I is equal to 2. All right, so that's denoted right here. I is equal to 2. So if m is less than x sub I, okay, so if m, which is currently set to 77, that has not changed, so we'll record that there. I is 2, so x sub I is 54. We want to see, is 77 less than 54? Right? That's the check that we have to do. And I'll just make a little note here. I is equal to 2, so we're checking, is m less than x sub 2? And recall that x sub 2 is our value right here, 54. That's why we're comparing it to the 54. And so let's see, is that true? No, that is not true. So we don't change our value at m anymore. We only say if m is less than that, then we'll reset m to be this new value. So We loop around. Now I is going to be equal to 3. We can see that right here. So that's still with us. I is equal to 3. Now we're going to be comparing m to the x sub 3 value. X sub 3 is 95. So is that true? Is 77 less than 95? Yes, it sure is. So we get to execute this line. M is less than x sub 3. And we're going to replace m with the new value. So now m is going to be this new value, which was 95. Okay, now we step through, looping around. I is incremented up to the next number, which is 4. So I is 4. We're going to be comparing m to x sub 4. So let's highlight that. All right, we got to check that. So is m, currently 95, is that less than 101? Yes, that's true. Yes, that's true. So we're going to set m to be this new value x sub 4. In other words, m is now going to be 101. Looping around, I is equal to 5. We see that right here. We're going to be comparing m. Is m less than x sub 5? Is m, which is 101, is it less than 62? No, that's not true. So we don't execute this if statement. Nothing exciting happens. We still have m being 101. And we loop back around and we say, okay, for I in the set, well, we're already done with the set, right? We already did our check for I up to the max value of 5, so there's nothing more to do. And so we stop at this point. So at this point, there was 1, 2, 3, 4 comparisons that happened in this code. And we can kind of see that here. When we look at the code, you know, there is our operation we're looking at, that less than symbol. And we can see that the for loop had 1, 2, 3, 4 different index variables. So that's why we can see we looped through there 4 different times. So there's 4 different comparisons that happened. But this is the trace, and it just shows you step by step what's going on with the algorithm.